And then 6.4.2 over here says at 15 minutes, as we mentioned in another disturbance, the temperature was changed. Use Le Chatelier's principle to determine whether the temperature has increased or decreased. Explain the answer. So this is a 4-mark question, and it did have to do with what we were talking about up here for 6.3.3, this made up question, where we have increased heat in the system, where our heat is over here. So as we could see, there was a sharp drop previously for the 5-minute mark, which means we decreased the concentration of CS2. Over here, we had a sharp increase, okay, at 15, which means our temperature has increased. We increased the whole temperature, therefore affecting the rate of our reaction. If this dropped again, we would have decreased our temperature. So right now, for the first mark, we can just go ahead and write increased, because as we can see, the rate has increased very suddenly, meaning heat has been introduced into the system, which means if we have increased the heat in the system, just like we were talking about here, we are then favoring the reverse reaction, because the forward reaction is exothermic, which means the reverse reaction is endothermic, which just means we are favoring the reverse reaction. So we have written that it has increased because we're seeing this sharp spike in the rate, and an increase in temperature favors endothermic reaction. By that, once again, this is an exothermic reaction, but because heat is increased, it's favoring the reverse reaction because we added too much heat, which means it needs to go that way, which means if forward is exothermic, it means reverse is endothermic. And there was too much heat, which means some heat is going to end up moving on this side, which means our reverse reaction is favored, as we mentioned, seeing that our reverse reactions rate is above that of the forward reaction, and then they slow down to equilibrium. And then another mark for saying reverse reaction is endothermic.